Before we go through lecture 4, fluid static part 2, we just review what we learned from the lecture 3. We learn about the pressure that P is equal to gamma H or equal to rho GH, or sometimes we write in terms of the specific gravity of time the density of water times GH. Okay, and in case of the H is the, if we prove that upward is positive, so we expect that we got the negative gamma H, but if in case of H, the downward is negative or positive, so we got the positive gamma H. So then we apply this. Next we go further to understand the pressure prism method. Okay, in this, assume that we have vertical wall with the constant width W blocks the fluid. How does the hydrostatic pressure from the fluid acts on the wall? So that is the width of the vertical wall. Okay, and we apply the hydrostatic pressure dP over dz equal to minus rho g. It assumes that the upward is positive. So that is, so we do integration dP from P to PA and Z from Z to H. So PA is from this point to the surface. And we can derive the equation of P equal to PA plus rho G H subtract Z is the equation 1. In this case, if we assume that if Z is 0, so it means P is equal to PA plus rho GH. Okay, so that is what we got from this. That's P equal to PA plus rho GH. Okay, and from the this pressure distribution for both PA is the atmospheric pressure on both sides. Okay, and next, if we find the force dF is equal to pressure times area. Okay, and equal to, for the pressure is P dA, and area is the dA is W times dZ, so we got PW times dZ. If we substitute equation 1 into dF, so we got this equation, and because dF is from the difference between dF1, dF2, and dF2. Okay, so we substitute dF1 and dF2 in this equation, so we got the equation 2, and this one some can be cancelled, this term and this term. Okay, and next we can do integration of force between 0 to H dz. Okay, and finally we got the F is equal to the next equation, rho W GW times Z square over 2 from H to H, from 0 to H, and finally we can get this equation for force acting on the vertical wall. Okay, to derive this, the equation of force, we can do in terms of the prism. This figure shows the prism that we can estimate the F is equal to the average pressure. This pressure is 0. It's the gate pressure. So pressure on the top of the triangle on the bottom of the triangle, so we can find the P is just the P top plus P bottom. Take average of pressure times area. So P top is 0, P bottom is rho G H divided by 2. The area is the H times W. Okay. So we can get F is equal to 1/2 rho G W H square. So it's similar to what we derive from the from differential equation, okay, or we can derive from the prism concept. Okay. The next, if we want to find the location of force or find the momentum, so we can find the summation of moment around point O is 0. So this is point O. It's point O. And moment around point O is equal to Z times df. And next we substitute equation 2 in this equation. Okay, substitute df in this equation, in the equation of moment. And next we can do integration moment from 0 to h dz. Okay, and integration of h dz is equal to h square divided by 2, and z integration of the z square is equal to z power 3 divided by 3. And finally we get the moment around point O is equal to 1/6 rho G W H square H power 3. Okay, this equation can give more detail that is the H over 2 H. No. If we substitute H in this, yes, so we got the 1/6 H over H power 3. Okay. And another way that we can find by using the prism or triangle. For example, we know location of the force. If you know the centroid is some point here, and the height of centroid is 1/3 of the height of the triangle. So we can find the moment. That moment is equal to point O is equal to F times H over 3. So we just substitute F 1/2 rho G W H square and the centroid H over 3. So we got 1/6 rho G W H square. Okay, so it's both equation is the same. The left hand side from the integration and right hand side from the prism method. Okay. So actually the acting force in terms of the prism is acting on at this point we call the center pressure. Okay.